Welcome to the first ever engineering mechanics tutorial. Today I will be discussing about the introduction of the engineering mechanics as well as the Newton's law of motion. So, for the introduction for engineering mechanics may be defined as the science which considers the effects of forces on rigid body. Engineering mechanics is divided into two parts, statics and dynamics. So first, statics, it deals with the effects and distribution of forces on rigid bodies which are remain at rest or in equilibrium. Next, in dynamics, it is the study of body that is in motion after the application of the force. Under the dynamics, kinematics is the geometry of motion, while the kinetics is the causes of the motion. Newton's law of motion. Sir Isaac Newton, an English mathematician and physicist that formulated the well-known laws of motion. These laws of motion are the foundation of the engineering mechanics. Newton's law of motion. It describes the relationship between a body and the forces acting upon on it, and its motion due to applied force. The first law of motion states that a particle at rest or continues to move with uniform motion in a straight line unless it is impressed by an external force. In this slide, I will be showing some of the illustrations of Newton's first law of motion. First is the launching rocket. As you can see, the net force is going up and the weight is inversely proportional to the net force as always, and the thrusters are the external forces that makes the rocket go up. For the next example is the ball kick by the player. So the ball is at rest, then the external force is the feet that will kick the ball to- towards in it. So the Newton's second law of motion. The acceleration, denoted as A, of a body caused by the resultant force is directly proportional to the magnitude of the resultant, denoted as F, in the same direction as the resultant force and inversely proportional to the mass, denoted as M. So, as the definition states, it will form at this formula A is equal to F over M, where A is equal to acceleration, F is equal to the resultant force in Newton, and M is the mass of the body in kilogram. Also, you can get the mass by by putting in this formula M is equal to W over G, where M is the mass of the body in kilogram, W is the weight of the body in Newton, and G is the force due to gravity equal to 9.8066 m over squared, s squared. Take note that 1 Newton is equal to 1 kilogram per meter over s squared. So take note that the acceleration, denoted as A, is the same direction as the resultant F. As you can see, the A here is just the same with this resultant line here, resultant F. Next is the third law of motion, Newton's third law of motion. For every action, there is an equal and opposite reaction. So this is the illustration of Newton's third law of motion. So as you can see, the red box here, or the object here, we can see that it is near with the W, and the W is represented as the weight of the block. And as we can see here, downwards of the table, the N is represented as the reaction force normal to the plane. While the arrow, as you can see, is both opposite direction. This represents that in every force that we make, there is an opposite reaction or equal reaction that we could get from it. And thank you. That's the end of the tutorial.